Okay, we're live. So this is oh, it's too high. Hold on a second. I'll put it down a little bit. Is that better? Okay, just let me know if it's still too loud. All right, so this is too low now. All right, I'm gonna put it at 35 right in the middle. I'll be happy for everybody. If it's too low, just lower the mic a little bit with the volume, I guess. All right, so this is gonna be our situation here for today, guys, with the topology that we're working with. Now, this is gonna be as the title says, it's just gonna be DMVPN Part 1. So this is just gonna be an introduction to what's to come. Basically, as we all know, frame relay is going to be replaced with DMVPN, and with that being said, it only makes sense for us to actually go into it and start playing with it and get accustomed to it and used to it. And that's pretty much what we're going to do here for tonight: is get used to it, start seeing a little bit of the command and a little bit of the theory. So this way we can, moving forward, any topologies that I personally put together, I'm just going to go ahead and just use a DMVPN cloud instead of doing a frame relay cloud. So this way it's kind of, not only for myself, but for anybody else who's going for the new CCIE version 5, we'll already be used to it instead of us playing with the, old frame relay. So for the guys watching the video recording, a little bit about myself. My name's Will Zambrano. I've been doing IT for about 8 years now. A lot of consulting, worked at different companies, teaching, a little bit of my rap sheet here. And as always, my little commercial blurb, I want to bring you guys over to our meetup page. So this is our meetup page. Actually, I changed the URL to NYC Networkers. So it's meetup.com/NYC Networkers, just because I'm slowly getting away from the Cisco name, making it more regional. So NYCNetworkers.com, this is all the, this is going to be our calendar, and all the upcoming events are coming up here. So that, and we also have a NYCNetworkers.com page here where, for example, today's lab is going to be under CCNP Security. And there's documents, there's a directory to our YouTube channel here. So the meetup page is here too. And just stuff I find in the field or whatever, that I think is interesting to put up here, I'll put up as a blog post as well. And the YouTube channel as well. And the good thing with the YouTube channel is, guys, just go click on playlists. And then you can see I try to categorize everything either by the CCNA level or the CCNP level. So if you guys want to see more information about CCNA security, I got a couple videos on here already on that. And my thing is you can skim through them, see take what you like, see what you like, or make any comments, and let me know what's go. If there's anything that needs improvement and whatnot, which I'm sure there is. So also here's my information here, willsandbrown@gmail.com, and I also have a Skype handle name, which I'm usually always on Skype, so feel free to reach out to me with that. Okay, so and actually before I get into the configuration here for today, guys, or the theory, I want to give you just fly down to the additional references. So I already have these already open here, the additional references. And a lot of the stuff that I'm going to do here today, guys, is nothing new. A lot of this has been taken from the knowledge-based articles, configuration guides, and literally going step by step, going through these white papers and reading about what DMVPN is about, the configuration stuff that we need to do with it. And the good thing is that there's not too much to it. I'm hoping that this meetup doesn't last, more than an hour. It's pretty straightforward. It's generally the same config, pretty much over and over and over. But of course, just like anything else, if we haven't seen it for the first time, it's gonna look funny and weird to us. So I'm hoping that the lab that we're gonna do here for today will kind of help us get accustomed to that. Okay. So let me just go quick. Let me do like a quick 10 minutes on theory here for anybody who's not familiar with DMVPN. So the big picture here. This picture here I took out from a Cisco article, and the whole idea behind DMVPN is kind of like, I guess you could say, smart point-to-point tunnels or smart VPN tunnels, where instead of how we had it traditionally, so let's say we have two, in this example here, we have two hub sites, and we have multiple branch offices or teleworkers. Traditionally, what we had to do was have one tunnel from the branch office all the way to the hub site, and then you have an effect of basically having like maybe 10, 20, 30, or whatever it is amount of remote sites connecting into this concentrator or an ASA or the old VPN 3000 concentrator, and everybody talking to that concentrator in order to go back down to a spoke for whatever reason. Now, the good thing with the DMVPN is that we don't have to necessarily have initial connection. Yes, we do have to have with the hub, but we could actually, as you can see with the little green lines here, we could also actually have spoke-to-spoke tunnels, or they call these phase 2 tunnels, which I'll get into in a second. But we can actually have tunnels created dynamically on the fly for us between these branch offices or these spokes without having to necessarily get the hub involved with that data plane traffic going through. So that's the whole gist of the idea of it. It's pretty much very similar to what we have with frame relay. As I have here, just like our frame relay connections, it's just a way to connect multiple sites together. Very similar to how DMVPN does, or frame relay does. So from that standpoint, from that objective, from that goal, it's pretty much the same thing that what we're used to doing with frame relay, except that now it's a different format. So it's something that we have to get used to and have to get familiar with. So also another thing with DMVPN, it's actually been around for over 10 years. It's been around for a while, and if anybody is from a security background, if you guys actually took any of the CCNP, specifically the CCNP Secure course, they do talk about DMVPN in there. So if you guys actually want some more information on that, more like a little beginner's intro, and I know I'm jumping between the slides here, but the Cisco Press CCNP Secure course, go to chapter 17. It's about a 20 or 30 page document chapter there that talks about deploying DMVPNs, the background, the initial configuration, and this is where I initially went actually myself, because I did a little bit of homework on it, and I figured, you know what, where do they teach this? And it's not in the routing and switching, but it's in the secure track. So just in case you didn't know about that. So yeah, so it's been around for a while, nothing new. At least maybe for us routing and switching guys, it may be new. I already mentioned like a traditional VPN tunnel. The spokes can now dynamically create tunnels between each other instead of having to go through that hub, which traditionally we've always had that point-to-point connection. Another thing too, out of the box, tunnels aren't encrypted, but what we're going to do here is actually doing the initial regular tunnels between the spokes and the site, and we're also going to go ahead and put some crypto ISACAM statements in order to do that crypto or IPsec tunnels, so we can encrypt that GRE tunnel. So out of the box, it's not configured for that, but of course, if you're doing anything over the internet, chances are we're going to want to get that. We're going to go ahead and want to get that internet traffic encrypted. Also, the hubs and the spokes advertise out via an interior gateway protocol or static routes for ways to get into each spoke, and that'll make more sense as we get into the lab here today. I'll show you guys what I mean by that. Also, but the hub, as you can imagine, like they call it the DMVPN server or the head end or the hub server. It learns. It's kind of like the main central point of all the spokes. So this way, there's like a big list, like a big laundry list of all the different spokes that have registered with the DMVPN server. So it keeps track of all of them. So in case a spoke needs to get to another spoke, the server is able to provide that information, especially if you want to do your phase 2 tunnels. And if you guys actually dig through the configuration guides, and especially if you go to this guy here, this is for iOS version 15, but this talks, and let me bring it up here more. This talks a lot more about what DMVPN can do. Configuring the hub, we'll take a look at today. Configuring the spoke, as Paul mentioned, you could also do MPLS. We could do BGP. We do QoS. Where's my QoS? Is that a different doc? Yeah, QoS on there. We could also do multicast traffic. We can pass through there. It's VRF aware, so if you have multiple VRFs in your topology, it'll take that as well. So it's very flexible, where it can carry over a lot of traffic over what you currently have already. So as you can imagine, this is setting, at least for any IE candidate, this is setting setting us up for a very unique topologies. So definitely look forward to a couple more. Maybe I'll do like a in the future. I'll do like a part 2, part 3 involving more of these technologies in here. And as usual, anything in the IT industry, never have a single point of failure. So in our situation here, in our topology, we have one DMVPN hub or server, which is going to be R1. If you guys actually take a look at the links that I have at the end of the PowerPoint presentation, Cisco actually talks about multiple DMVPN servers. So one of the topologies that are models that they call a dual hub dual topology. And basically, it's just a way of like, you know what, don't put all your eggs in one basket. Definitely have at least a second one in place. Kind of going back to the Cisco white paper here, we do have 2 DMVPN clouds or sites here. So, but we're not going to do here for today. I just want to show you guys the basic config. There are 2 main modes: hub and spoke mode, where all of these spokes talk to each other via the hub, or a spoke-to-spoke mode, where the spokes don't need the hub, but they query the hub, or they ask the hub what the, and I kind of mentioned that before, where if the spokes want to talk to another spoke, they'll pull that public IP information, or they'll call the MBMA address from the hub. And we'll see that with a couple shell commands, which there aren't really too many, actually. There's like maybe, I think there's like 2 or 3 maybe for DMVPN. Now, one thing that you guys will start to see when you start to get reading about DMVPN, they talk about phases. So I was a little confused at this at first, because I'm like, I'm thinking IPsec, phase 1, phase 2. I said, that's the kind of frame of mode that I had. But in reality, I think they should have probably named it more models or implementations. And especially if you guys go to like Cisco Live 365 and they talk about the different phases, you'll want to differentiate what's phase 1 versus a phase 2. So a phase 1, when they talk about that, when you guys read documentation or the Cisco Live videos, it's just basically your traditional hub and spoke. Nothing really crazy. Stuff that we're pretty much used to already. The phase 2 is going to be our spoke to spoke. This is what the whole purpose of having DMVPN is in the first place. Most people want to have this functionality. Or a phase 3, which they call this an advanced spoke to spoke or a hierarchical spoke to spoke. I have not played with this yet, so I cannot comment too much about that. All I know is that it wants a higher revision of the code in order for you to actually get phase 3 on there. Okay, a little bit of 2 terminologies that you want to know, as I mentioned previously. Hub, head-end, NHRP server. Whenever you hear these terms, they're one and the same. Same thing with spokes and NHRP client. These are the same exact thing as well. The spokes, clients, hub, server, they're all the same thing when you hear about that. Okay, and this is pretty much stuff that I already kind of went over already, so I'll just skip that part here. Also, let me jump real quick here to Cisco Live 365, even though they don't call it 365 anymore, which that's why I crossed it out on my little PowerPoint here. But I wish really somebody told me about this, actually, when I was a CCNA or at least an MP, because there's so much free information on here. You have not completed your account. Oh, too bad. All right, there's so much free stuff on here that I wish someone had told me about this earlier in my career. So, for example, two videos that I actually took a look at, and there's not too many actually, but DMVPN deployment models and advanced concepts, and these are breakout sessions. And if you actually search for these numbers in Cisco Live 365, they'll pop up. So there's a little video download here, and these, as I mentioned, if anybody has saw the CCNA data center ones, that's what I use to actually study Nexus, since there wasn't really that much at the time. There was not that much material out for Nexus. But the thing is, if you guys are learning for the first time, I would not. I wouldn't recommend going to Cisco Live first, because they're really high level, not high level, very deep talks. So if you're not familiar with the technology already, you're kind of going to be a little lost. Better, start off with the Cisco Press. Check out some free YouTube videos. I know Keith Barker, INE, has a couple free videos out there talking about DMVPN. Try those first, and then finally go with the Cisco Live material as kind of like your, icing on the cake, because they go into really, really deep details that probably, for our purposes, for the CCIE version 5, we probably don't need to know. It's more of under the hood. Okay, so that's it. That's all the theory. I mean, not too much with it, but let's go ahead and actually jump into this lab. So right now I just have a basic flat I just have a basic topology here. There's no IGPs configured, just IP addresses, site north, site southwest, site southeast. It's all /24s, and internally in this little blue, like our little provider network here, I have a 108 network. And what we're going to do, and when you guys see in here where it says DMVPN tunnel, that's actually going to go ahead and that's going to be the IP that I'm going to put from my tunnel, or my GRE tunnels, which will eventually become the tunnels I'm using to set up DMVPN in the first place. So let's go ahead and sort that out. So number one, let's go ahead and configure routers 4, 5, and 6 for NHRP AS1 and advertise everything out. So let's just do that. Let me see what I got in the first place. Do I have anything shut down? No. Okay, nothing there. Now, 4, 5, and 6, as you guys can see, they're on the outside of our topology here. So at this point, we're not expecting any adjacencies to be forming. Next up, for the following DMVP setups, do not configure encryption, just plain old GRE tunnels. That's going to be our next part. But right now, let's just do regular basic tunnels. Which actually, I'm pretty happy that I don't know if anyone has actually taken a look at the new CCNA material. They actually now they briefly talk about tunnels now, which is pretty nice, because for a while they weren't really talking about that for whatever reason. Yeah, I had to do my own homework to figure out what were tunnels in the first place. Actually, yeah, let me see if I can make these a little bigger. I'm going to have to disconnect and reconnect. Oh, you know what? Let me do this. Alright, that makes my window a little bigger. Alright, Francis, let me know that looks okay. Actually, I probably should have done that in the first place, because I know when I looked at the YouTube video, it was really small. Okay. Alright, so let's go ahead and configure R1 as our DMVPN server, hub, whatever you want to call it. But I'll just call it DMVPN hub, since we're used to that whole hub and spoke topology setups. So for that, I have my little cheat sheet here, which you guys can also actually use at the same time as well. we're just going to create a regular tunnel here. So this, and maybe this too. This is all commands that we've seen before when we're creating tunnels. There's nothing really different here. As you can kind of see though, those IP NHRP commands are new if you guys haven't played with it before. And also if you guys even go to one of the Cisco white papers and just click on, and I'll put this in the chat so you guys can see it. If you guys actually even go to that, to a couple of the white papers and just click that, and you can see their summary steps. It's pretty, I mean, there's some stuff in here I didn't include because some of the stuff is optional, but I pretty much just, you know, put like the bare basics in there in order for us to get that tunnel up in the first place. So on your own time, guys, definitely play around with these different commands here. See what works, see what doesn't work. You know, that's the best way I personally used to learn, is just try different combinations, see what works, see what doesn't. And the nice thing with DMVPN is, I mean, it's steps 1 to 16. You know, this if you miss one, you can always refer back to the config guide here. Yeah, no, Paul. Yeah, you're right. We don't need the MTU. I know a lot of the videos and documentation I read, they said in the real world production you should use the MTU. That's why I have it in what is this thing? Italic, because it's optional. But I just have it in there as a way, like, you know what? I mean, you guys can use it if you want. It's not gonna break anything if you do, but I'm actually not gonna use it. That's why I have it at the bottom. This is all I'm gonna do. That's like my bare bones configuration. And I think some of the documentation shows that you need a, I'm going to bring it back here. They say that you need a IP NHRP authentication command. I didn't put one in, and it works fine. So, you know, we'll see what else I guess we can strip off of this, and, you know, as like a bare minimum configuration. So I'm going to have it on the side here. And if, by the way, if you guys want to take a screenshot of this, you know, go ahead, take it right now. I'll give you like a couple seconds. This way you kind of have it in front of you as well. Or just click on the link in the chat. That'll bring you to the same section where I have the config guide. Okay, so let's go ahead and do this. So let's do tunnel 0. We'll give it the IP address of, I said 1111. This is like, if you guys have been seeing any of my PowerPoints, it's just my placeholder. This doesn't really mean anything. It's just saying that it's an IP address. But I'm looking at my topology here. My DMVPN tunnel, or that's the tunnel is going to be for DMVPN, is going to be a 172.16.100. So I'll call it .1 because it just makes it easier for router 1. All right. I'll do the IP NHRP. Let's do a question mark so I can take a look and see what toys, what little knobs here I can play with. There's my authentication. Next hop server, we're definitely going to need later on. Responder, we don't need that at this point. But let's do map. Where's this map command? Looks like it's a hidden command. It's not even in there. Oh yeah, it is. I'm going blind. Alright, so map a destination IP address to an MBMA address. So MBMA is going to be the public IP of our spokes. And I believe INE mentioned that this is almost analogous to like our frame relay map commands. So you kind of think of it in that sense. So let's do a question mark. We'll do multicast. And then we'll do dynamic, in case we have any multicast traffic here. And that's something I just pulled right from the config guide. I didn't make it up. You know, there are, I think almost every video I've seen, people explaining DMVPN, they mention this as well. And if we go to 7, we can see here that this command here allows NHRP to automatically add spokes and routers to the multicast NHRP mappings. So we might not even need that, actually. I'll probably play with that later on. I just know there was one of the steps necessary for that. Next up, I'm going to put NHRP network ID. And this could be like any number you want to, so I'll just call it 2014 for today's year. This way it kind of stands out a little bit. Next up, I'll do tunnel key. I know Paul mentioned that we don't need a tunnel key, but I will put one in there, and then we'll remove it once we get the tunnels up. By the way, I don't know, Paul, I don't know if you had a chance to use actually certificates to get the tunnels up, because I was playing for like a good 2 hours trying to get the certificates working. The tunnels actually would stay up when I put in certificates on those 3 routers. Okay, cool. Yeah, definitely the either you can use the iOS certificate router or the full-blown Microsoft, the Microsoft CA, which is what I was using actually. That's coming in part 2 though. I'm not I'm not done with that yet. All right, tunnel key. So this is something that we have to have on our hub and our spokes as well. So as we go back to our guide here, we can see tunnel key. Here it says it's optional, so we probably don't even need it. Well, the guide says it's optional, so you know what? I'm not even going to put it in. Well, it looks like you are right. So let me go here, and I will cross them off. Let's see what happens. We'll definitely need a tunnel source, though. Say where we're going to source this traffic from. So let's go back to my GNS3 here. I'll hit the label so I can take a look and see it's F00. Done. Next up, the tunnel mode. So if you guys played with tunnel mode before, this is sometimes you may, at least when you were back in CCNA, they talk about converting IPv4, IPv6, and back and forth and all that kind of stuff. And sometimes you will have to change the tunnel mode depending on the translation you're trying to do. But for what we're trying to do here, we want to specify GRE and say multi-point because we're going to actually have 2 routers going into router 1. And tell them state change to up. Now, when you guys take a look at this, don't think like, oh yeah, everything's working right. You know, everything's working fine now. You know, we just touched router 1 right now. We didn't even touch router 2 or router 3 yet. So this is a little deceiving. If you're playing with this for the first time, just because it says it's up doesn't mean. I mean, I can't ping anybody else at this point. I haven't even configured the other side of any tunnels at all yet. So, but if you do get that to say up, that's never a bad thing. Okay. This stuff is optional. Let me see what the config guy says about that, because sometimes they say. Funny enough, the config guy here says it's not optional. It just not like what we had with our tunnel key, but it is. You know, it's just one of the things that you play with, and you know, I was trying to have different combinations, see what would work, what wouldn't. Okay, no problem, Charles. Just email me, and I'll send you a copy of the PowerPoint. Okay. And that's it. So let's go to our spokes here. So we got 2 spokes, router 2, router 3. If you guys want to take a screenshot of this, you know, now's your chance. Actually, since we didn't specify a key on the hub, I'm not going to specify on the spokes. Alright, so let's start with 2. We'll do our ton 0. We'll give it an IP address. What's 7.2.6.8.1? Oh, wait a minute. Did I give you guys? Why does my topology say 192.168 and lovely. I have a typo one here. Okay. Ignore ignore the .NET file. Go with the PDF. My fault on that. All right. IP address there. We'll do IP NHRP, network ID, we said it was 2014. Tunnel source is going to be F00. I believe everybody should be, yeah, 0000. The source of that traffic, we're going to do also a tunnel GRE multi-point. Changed up already. Now a couple new commands here that we have to do, and I'm going to cross-reference this with the config guide here. Let me jump back up to the top. Configuring spokes. So you can see here that we actually have a couple more steps that we need to do to get the spokes working. A lot of this is really similar. Interface tunnel, let's give it an IP address. We know that these two are optional. These guys aren't optional. This is not optional. We of course have to give a source for all this traffic. Tunnel keys optional. Let me see actually if it's in here. Does it say it? Yeah, it still says optional. So let's go ahead and put that in. NHRP map multicast. And then you can see here that I have just 1111 as a placeholder here. So this is actually going to be the actual real IP of our hub interface. So we actually have 108.70.194.1, I believe I gave. Yeah, 194.1. That's going to basically say where am I going to send this multicast traffic to. All right. Next up, I'm going to do a IP NHRP map. And over here, I have a 1111 to 2222. This is where the question marks going to come in handy. So let's say the IP address of the destination. So let me just put that in here. And then notice over here, I mean, this is my placeholder. I'm going to come back to that. But notice here the second IP, it says the MBMA address. Whenever it says MBMA, think of public. Think of like the actual real IP. So this first 1111 here is going to be the IP address of the tunnel of the other side. So we said this was a 172.16.101. And then I'm going to map to get to that 100.1. Use this public MBMA address, which we said was 108.70.194.1. And that's it. Looks like you can specify multiple, but we only have one in this case. Okay, that's these guys. So we'll do one more, our next hop server. Once again, going back to the config guide here, that's going to be step 9. And you can see here that this command here actually configures the hub router as the NHRP next hop server, or telling the spokes what's the next hop. So we can do next hop server. In the PowerPoint, I have a placeholder 1111, but in reality, that's going to be the other end. Over the tunnel. Ah, my performance is slow. Lovely. Okay. And that's pretty much it. What we have to do. So let's go to Route 3 and let's do the same exact. But you know what? Let me go down to the part where we have the tunnel. Grab this guy, notepad, throw him in there. And the only thing we're going to change here is I'm going to make it .3. Missing a source. Hold on a second here. Actually, I have it right here, Paul. I don't know what you I don't know what you mean. Oh, it's not? Yeah, it's right here. You definitely want to have a source, man, because you're not gonna you won't have a starting point for your tunnel. Okay, so let's jump to 3. This is pretty much a copy and paste in our case because all the and by the way, I purposely made it pretty much copy and paste. I mean, if you guys are doing this for the first time, definitely type it out. Don't copy and paste it. You know, get used to the config. Get accustomed to it. You want to get to the point where it's almost muscle memory, which I personally don't have. I don't have right now with DMVPN, since I don't play with it all the time. But at least, you know, let's talk lab time. If I'm going for the lab, of course, it's going to be muscle memory. But for, you know, our educational purposes here, definitely at least try to type everything out and use it and abuse the question command. So this way you get used to, you know, what the different options you do have. Okay. So let's go to the hub. Let's see what we have. Show IP. And let's see, do we have anything? So this is one of the, and I think I have a slide for that. Yeah. DMVPN verification commands. So actually I threw in here a couple more extra ones that we may or may not need, but of course the basic one, show IP NHRP, will show you all your spokes. Show IP NHRP brief. Let's try that. Just a little bit of a cleaner looking output. So what this is telling us here, the target. So .2 and .3 is going to be router 2 and router 3. I learned it from these tunnel IPs here, which is in our cases they're one hop away, so that's why they're the same IP. If we had like if we throw in here something like BGP or something or made it more complex, they'd be different IPs. MBMA. This is, and once again, when you guys see MBMA, think of public. And my PowerPoint here cropped out. But whenever you see MBMA, just think of public IPs. So you can see .2 and .3 belong to router 2 and router 3, and going over our 108 network or provider network. And I dynamically learn them. Okay. Now, if I take a look also here at the full output here for my show IP NHRP, I can see here that I learned .100.2 via 100.2, which pretty much is the same thing that I'm seeing down here. I'm learning through tunnel 0, which was created about 3 minutes ago. It'll expire if there's no traffic going over. So if I say, is that going to go down? Okay. Probably not. So there's probably like some kind of keep alive or something going there, keeping that up. But we can see how long this tunnel's been up. I learned this dynamically. So the tunnel formed dynamically here. Flags, I'm not too sure about this just yet. I'll have to get back to you guys on that one. And my MBMA address. This is my public address that I learned it on. So actually, I kind of like the brief better. It's kind of like my show IP interface brief. It tells you what you need to know in like a quick and dirty way. And the interface I learned it from. We also do summary. So NHRP cache, 0 static, 2 dynamic. This is, if let's say hypothetically that maybe we had like dozens of tunnels. This will give us kind of like the, as the show command implies here, a summary of what we're looking at. So let's take a look at our spokes. Let me see, do they give us the same information? And I can see here I statically learned this one here. So never expires because it's a static config. And static is because actually we did these map commands here. And notice that we didn't do any of those map commands on the hub. What else do I have here? Traffic. Show NHRP traffic. So if you want to see if there's any, as the name implies, traffic being passed through, you can see any of these counters going up. What else we have here? We also have show DMVPN. And usually I like these like basic commands here because they should give you usually like a big picture of what you're looking at least to start off with. Actually, let me do that command on the hub. Show DMVPN. So this is kind of similar to that show IP NHRP command. You can see that I learned my peer MBMA address. Once again, when you see peer, just think of, you know, almost do like a knee-jerk reaction. You think of MBA there. Talking too fast again. MBMA, you think of public, and peer, this is going to be your private, or the actual peer IP of the tunnel. And we're up right now, so this is a good thing. And what's attribute D? D means I learned it dynamically. So whenever you actually guys take a look at this kind of stuff, especially DMVPN or any kind of new technology looking at it the first time, just read through the output. You know, don't like, you know, think like, oh, I haven't seen this before, I don't know what it means. This is one of the reasons I switched to Cisco. I became a Cisco believer because it's so easy to read sometimes. The answer is usually right in front of you half the time. Or as you get more and more exposure, you can kind of piece together what the output's trying to tell you. We also have some clear commands here, so if you want to blow out some configs for whatever reason and start from scratch, DMVP, do I have it wrong? Probably clear just DMVPN. Yeah. Clear DMVPN sessions. So if you want to, you can blow out a particular peer, as you can see here, or per interface, or you can just say everything, and it kind of blows everything out. So if I do another show DMVPN, or NHRP summary, nothing's on right now. And there's nothing there either, which maybe I shouldn't have done that. But yeah, so that's off. You don't want to put that in there. Just clear DMVPN sessions. Let's hope that comes back up. If not, we'll have to troubleshoot that. Okay, so I see this is an S. What is S? Static. Okay. All right, so let's do some pings now. Kind of that I broke things over here at the. Oh, there we go. It dynamically learned it again. Perfect. Just what I was hoping it would have done. So, and my lovely Adobe's not working. Let's bring this back up. Okay, so we kind of actually did two steps in one. We did configure router 1 as our server, and configure router 2 and router 2, actually configure router 2 and router 3 as our spokes. So that part we did already. So step 4, let's ensure that routers 4 to 5, actually 4, 5, and 6 can ping each other through the DMVPN cloud. I need to proofread these things. Holy crap. All right. So let's do that. So let's go to 4, 5, and 6 are going to be kind of like our end users, I guess you could say, or our EIGRP domain that's supposed to be forming over this DMVPN cloud. So let's do, again, EIGRP proto. I should be advertising everything out. Show EIGRP interfaces. So right now it's enabled on FA00 and loopback 0. But I'm not forming anything right now, so let's jump to, since we're on 6, let's jump to 1. And do a show run section router. Do I have anything? Okay, I don't have anything here. So this is going to be a problem because I'm isolating basically routers 4, 5, and 6 right now. So I'm gonna have to create some commands here. But the thing is here, you guys have to be careful here because you don't want to enable. I mean, it'll work, but we're kind of cheating. We'll be cheating ourselves if we enable this everywhere. So we want to pretend. We just want to enable it for the 172.16.1 network. So I'll do my knee-jerk reaction, no auto, and 172.16.1.0. 1. Okay, so I got a new adjacency. And was it on the tunnel as well? Okay, let's see. Let's see what we have here first. Two neighbors. Okay, so I formed that neighborship over with router 1. So let's jump to 4. I should have it enabled everywhere. Okay, good. So let's jump to 2, because he's directly connected to 4. Let me do my show IP interface brief here. Okay. Want to make sure we're pointing to the 172.16.2 network. Knee-jerk reaction, no auto. And what we got? Anything? Oh, hold on a second. I fat fingered. There we go. Okay. So that's fine here, but are we actually learning anything over the tunnel? Neighbors, even better here. So you can see here that I'm not learning anything. I'll put basic just so I can stop complaining. Okay. So you can see here that I'm only learning through 0, 1, which is pointing to router 4, but I'm not learning anything over the tunnel right now. So if I take a look again at my NHRP commands here, which actually, let me kill this because it's not right. And Paul, you're jumping ahead, man. You're ruining the surprise. All right. So we killed that, but I'm not learning anything over. I want to learn the network from router 6 from site north right now, but I'm not learning anything right now at all. And kind of Paul ruined the surprise, but yeah, we do have to also enable EIGP over the tunnel as well, in order for us to, in order for all our sites to ping each other. So let's go ahead and do that as well. So if I do a show IP interface brief, you can see that I have my tunnel 0 and his IP of 172.168.100. And let me jump to router 1. And let's see what we get. Should be coming up. Don't you need to add it in the tunnel config? Let me see. No, 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 Paul. I never said I was the expert. All right. Is that the case? I would have already passed the lab by now. Okay. We should have gotten the adjacencies over the tunnel, but I'm not getting anything. Now, when I did this lab last week, this is actually one of the gotchas that I was wondering why this is not working, and we do have to advertise this network over the tunnel, well, our 172.16.100 network. So let's see if I can even hit the other ends, and I cannot get anything. Do show IP route. Let me see what I got here. 172.16. Okay. So 216. Let me see what I got for. Oh, do I have a typo somewhere? I have a 168 here. That would be bad. Yeah, that would definitely not work. So I want to keep it along the document. So let me change the tunnel IP. Let me jump over to 3. Oh, wait a second. The second I did that, the neighbor came up. And nothing's going to come up here yet because I didn't configure anything NHRP-wise on here. So let's try this now again. Okay, that's good. Let me do a show IP route again. And I could see that there. All right, so let's do router 5. Let's connect that over to router 1. So let me backtrack here. Let me see what we got. NHRP. Actually, no, we're good here. Let me jump to 3. Oh, I don't have anything on here, actually. No auto. And I also want to do 3, 3. Okay, so 2 adjacencies, 1 over to router 1, 1 to router 5, which is what I'm looking for. And I can see from router 1, I'm learning how to get to 4 and how to get to 5. So take a look here, guys. So we're on router 1, and I can, over the tunnel, go over to router 4 and 5. So I can ping the loopbacks, which is a good thing. Let's make sure we can do that with everybody here. 4 and 6. Perfect. Actually, you know what? Even better test. Let's go down here. 4. Can I hit 6? Yep, that's perfect. And I can't hit 5 for some reason. So Why do you guys think 5 is not working? How come I can't hit 5, but I can hit 6 for some reason? Any takers, not including Paul? I know, man. Don't say anything. Francis, come on, Francis, man. We were just talking. What? I know we're putting together that OSPF stuff, man. This is right up your alley, man. Gerard, talk to me. Talk to me. I'll give you a hint. This doesn't have to. This doesn't have to do with DMVPN. Yeah, pretend we're not even talking about DMVPN. Pretend that we're talking about we're configuring NHRP over frame relay. Why is this not working? Yeah, and we have a hub and spoke topology set up. I'm trying to find that. So if you guys here, you know what? Really? Oh, it's not letting me copy and paste. Which one is this one? All right, Francis, or anybody else in the chat who would like to take this up. Take a look at that PDF doc that I just sent you. And scroll to the EIG. I just had it. Where is it? Where is it? If you guys go to routing protocol configuration 218, EIGP configuration, the answer's in here somewhere. OSPF is also here in here as well. There's a nice thing about DMVPN. They do, they tell you how to configure this. So nothing that I'm showing you here, guys, is out of the box. It's all, you know, it's all known information out there. It's just that we may have not, you know, we're not used to it. Gerard, you win. You win the shiny penny, man. Split horizon. So let me show you guys. Smoke to smoke networks. Okay, let me get that. Here we go. This would be normally prevented by split horizon, but in addition, advertised route must contain the original next hop route, blah, yada, blah, 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 blah. But key is when I was when I was seeing this command down here for the head-in router, head-in server hub, whatever you want to call it, it's right here in bold. So what we want to do is go to 1. And actually, funny, now that you guys got that, I can show you right here. Configuring EIGRP. We want to advertise the tunnel IP into OSPF, or that tunnel subnet that we said, 192.16. 16, yeah, not 168. And do the split horizon, because that's an EIGRP thing. We're not even talking about DMVPN at this point. Turn it off on the hub router and under the tunnel interface with a no IP split horizon command. So let's do that. Let's go under the tunnel. The neighbors are going to reset. Let's go back to router 4, and we can hit 5 again. Yep, split horizon, man. It's funny how those little basic concepts, you know, that we forget sometimes. Yeah, I'm still in phase 1. So that's actually going to bring to my next part, actually. Do I have OSPF in here? Yeah, OSPF. So here I'm thinking that this is going to be an hour long, and of course it's never as long as I say it's going to be. As short as I say it's going to be. Okay. So now that 4, 5, and 6 can ping each other through our DMVPN cloud, next step, let's ensure that we can create, DMVPN phase 2 tunnels, so that we can create our dynamic tunnels, or our, you know, on-the-fly tunnels between the spokes, instead of having to go through the DMVPN hub. And how can we verify this? So lucky for us here, I did my homework a couple weeks ago, and I have my cheat here. So to enable DMVPN phase 2, and once again, phase 2 is just tunnel-to-tunnel communication instead of going through the hub. Make sure that we turn off under the tunnel interface the no IP next hop self command. So if we go back to the guides here, this is what the paragraph I was highlighting earlier. In addition, the advertised route must contain the original text learned by the hub route. A new command was added to allow this type of operation. So you can see in here under the tunnel interface, you can see in bold they have in here the no IP next hop self command. So this way, the hub router is basically taken out of the equation when it comes to routing. So out of DMVPN phase 2 is going to be set up for us out of the box when we put this command in there. So Paul's saying that we're still going to go through the hub for phase 2 for resolution. That's the whole query message. So initially we do need the hub, but then after we get there, our NBMA IP address, or the public IP address that we need, you know, we did basically got what we need from the hub, and then we can talk amongst ourselves. It's almost like, I don't know if anyone in here works with a call manager or IP phones. It's like, you know, once you get a IP phone conversation going, once the call manager does its job, the phones can sit there and do their thing. I can set up a conversation. Even if the call manager goes down, my phones can still talk to each other because that connection's already been established. So let's try it actually. So actually, you know what? Let me do. Well, it's too late for that, but let me make sure it works first before I start. You know, let's do a trace route to from 4 all the way down to 5. So that command that we put in should take hub 1 or router 1 out of the equation. So basically what it should look like is, instead of going up here to come up back all the way down here, it should look like this. Alright, so let's see what we got here. 172.16.2.2. That's going to be router 2 right here. That's this guy. And let's verify that. No, I don't want an extended ping. Alright, here we go. 172.2.2. That's this interface right here. Actually, I'll make this a different color. This guy right here. 172.16.100.1. I know that's this guy already, so this is off the bat not even working for us. On the intelligent interface, so the spokes can talk to each other. Did I put it in? Yeah, I put it in. Ah, yeah, that could be it. Could be cached. This is like the if you guys have been watching the CCNA videos, when we were playing between RIP and OSPF and NHRP, a lot of times we had to refresh the routing table just so it would like lose all those old entries. So let's like take a look at router 4 right now. Not M route, that's multicast. 5555. This is saying go to 22, which is fine. Let's jump over here. So to get to 55, it's saying go through 100.3. So it looks like the old information timed out, or cleared out for us. So let's try this again. And this is what I want to see. So like Paul mentioned, we could either clear it out to force it and give us that that resolution right away, or we can just wait for the old info to timeout. But so this is saying here go to 222, which we said was router 2. It'll jump to 100.3, which is this guy here, the tunnel IP for router 3. So he's out of the equation. And then finally we get to 3.5, which is which is router 5, which finally gets to 5555, which is a loopback. So that's it. Just that one command that turns on phase 2 or phase 2 implementations. Yeah, phase 3. I'll get to phase 3 soon. I only went to phase 2. It's only 2 commands. All right, lay it on me, man. Where did I put it? But before that, let me see. Okay, we verified this. We did the trace route. Let's add security. Okay. Actually, no, Paul. Let me finish up the objectives here, at least for the guys on YouTube, and then we'll do that afterwards. Phase 3. Okay, so that's all working fine here. Just to double check, let's ping 408 from 5, and that's working fine. And let me do my trace route. And that's going directly to the tunnel IP, not through the hub whatsoever. So that's working perfect. So now let's do our, right now everything's working with just naked IP, or just in the clear, or nothing's being encrypted right now. So this is good for now, but of course we want to add some security in here. So let's go ahead and do that. And the good thing is, I have that in. I have my little cheat sheet here actually. So what is this? This is actually info. I'll call it that. So there's a couple of steps that we need to actually get encryption over our GRE tunnels that we have set up right now. So first things first, and if you guys have actually made regular point-to-point tunnels before, and if you guys haven't, take a look at one of my old YouTube videos. I do go security. Do this one. Go to this video here. I talk about how to do point-to-point VPN tunnels. This is kind of similar to what we're going to do right now. So if you guys are used to that already, you'll feel right at home. There's not too much different from here. So let's start with one. We'll define an IKE phase 1 policy. Crypto ISACAM policy, we'll call it 10. We'll do Keith Barker's haggle, even though you have to do every single one, but I'll do it anyway. Pre-shared, which part 2, I'm going to get this working here. I want to get the certificates working properly. I had it halfway working, but I ran out of time and I just couldn't finish it up. Group, and lifetime, we'll put 84,000. Okay, so this this is going to be our phase 1. I'm going to do that across the board. No, I'll do it this way. It looks like it gets rid of my hash. Okay, so let's take this guy, and you can paste it to your notepad, or your palette as I like to call it, and we'll slap it on all the spokes. So everybody has the same phase 1 policy. Okay, next up we're going to, and actually before I even go into this part, what I'm doing here, once again, is all fully documented. So if you guys are wondering where am I getting these commands from, I'll email me, you guys, if you want the PowerPoint, or the most important thing of the PowerPoint is the links. Or if you guys are comfortable with Google, just go ahead and Google for these white papers and these KBs, and they're out there. They're not like nothing secret. So if you guys are wondering where I'm getting all this commands from, we're going to configure a local password to use. So I'm going to say crypto ASICAP key 0 meetup, I'll call it. And address, I'll say everybody can use it to make it quick and easy. And I'll paste that everywhere. Oh. I mistyped it. Alright. Okay. Alright. Third step. Now we're going to specify our transfer set, or our phase 2 portion. Now this is something that, like I said, if you guys aren't familiar with what I'm doing right now, refer back to that old video. I talk a little bit about what we're doing here. This is assuming that we're past the CCNA security level. Now we're going to link the transform set to the crypto policy, but we're going to do something a little bit different, because normally we would take the crypto ASICAMP, link it to the transform set, and apply it to we'll apply it to the ACLs and all that kind of stuff. But here, since we're doing DMVPN, we're going to do something a little different. This is where we kind of break away from our regular point-to-point tunnels. And I'll start with one. Let me get out of here. Crypto IPsec profile, and we're going to call it. Most of the documentation calls it the same thing, so I'll follow suit. And now what I can do here is set. So you can see here our transform set. So specify a list of transfer sets in the priority. Word, so I called it right here. This is what I call my transform set. Done. So that's me making or linking this transform set over to this profile, which I'm going to be using for my tunnels. And finally, I'm going to apply the IPsec profile to the tunnel interface. And actually, I got to do this for everybody, actually. So let me finish the config here. Tunnel protection, IPsec profile, and the name. Make sure you don't get that trailing space. Enter. So you can see here, ASICAMP has been turned on. The second I do that, I've made that tunnel, that GRE tunnel, IPsec tunnel, or encrypted tunnel. And I'm seeing here, I'm getting some messages here saying that my tunnels are down. I received a non-IPsec packet, which it doesn't like, because now I'm talking encryption and the other sides aren't talking encryption. So to do this, we have to do it, of course, for 2 and 3. So for this, I will just copy and paste it. Oh, I did that already. Okay. Actually, it's probably faster if I just put this on a notepad, but okay, so for router 2, ASICAMP has been turned on. My tunnel has come back to router 1. Up and up. I can see here my 100.2, which is my tunnel interface, has come back up also. Let me finish it off here. And that should bring it up for router 3 also. IP DM. Oh, that's right. Just okay. So that's good. I can see it has come up dynamically, and I can see the 2 tunnels up. So how can we verify that they're actually up and encrypted? Well, for one, we got that error message saying that we were getting not IPsec packets, but 2. At least for me, I know these tunnels are back up even when I'm using under the even here where I'm specifying the tunnel mode, tunnel protection, and the tunnels have come up. Yeah. Okay, let me just run my verification commands here again. See if anything comes out different. Dynamic, dynamic, dynamic. So I see here that I got it in here twice. My guess is these are starting to time out. Oh no, wait. When do I have multiple entries in here? That'll be for part 2. I'll find out why. It's probably just like the old, the original non-regular GRE tunnel, and then there's also the IPsec tunnel information here as well. Traffic. I'm just wondering if there's anything here that could show me if it's actually encrypted or just... and it doesn't look like it, actually. You just have to know that, that we did the right commands. Per static summary. Okay. And finally, to wrap up here for tonight, I also want to configure OSPF on these routers. Ensure that we have the same connectivity that we had when we were using NHRP. So actually, I probably should have done OSPF first, because then if I put them 2 together, they'll probably... AD will probably prefer NHRP, but let's see what happens. So if I go down here, I can see my OSPF configuration command here. Now, how should I phrase this? So if we're going to configure OSPF over a hub and spoke setup, what do we normally have to do with OSPF? And the answer is like right here. So you can see that we have to actually change the network type. So once again, this is no different than what we were doing with frame relay. So let's try that. I may have to kill EIGRP. Well, at least that's what the documentation here is telling me here. Unless there's another command here that does something similar. The doc is wrong. It would not be the first time, actually. But for us learning for the first time, let's go with the doc and so I'll do the same commands. This is router 1. And I'm basically just going to I'm just take a look at the EIGRP config. And just copy it over to the OSPF version. Which is not too different. Wow, there's something in the tunnel already. Okay, let's go to my routers 4, 5, and 6. And I'm just going to do the shotgun method here. Boom. Alright, here we go. So, there's a lot of stuff going on here with my router 1, but let's take a look at the router table. Now, I kind of thought this would happen. OSPF is kind of, or EIGRP is taking over OSPF, so I'll kill. I'm just going to kill it for everybody here. No router EIGRP1. So this way OSPF should take over. There we go. So I got a few. Well, I got one OSPF command here. That's going to but I still can't get an adjacency over that tunnel. It's enable on the tunnel. I could definitely ping it. Yeah, and Paul just got here. You can see here the state's a point-to-point. So in our setup here, we can see this is obviously not a point-to-point. This is actually like a multi-point. But let me go back to my documentation here. This is saying here that we should change this to a network broadcast. Actually, that's the way that I did it. Or, as Paul's mentioning, we could also do a point-to-multi-point. So here's my cheat sheet here, guys, for OSPF stuff. Of course, we want to advertise this tunnel in OSPF, tunnel IP, something in OSPF. Cisco best practices is to make the hub router the designated router for OSPF. And, of course, we could do this with our IP OSPF priority command. And depending on what type of topology we have, we could change the network type to broadcast. Or as Paul mentioned, we could also do the point-to-multi-point. Just to get this whole thing working already, and I'm over my 1 hour limit, I want to just do broadcast. I don't want to sit here and try to troubleshoot anything. I'll do that for my part 2. I'll make it more cleaner config, I guess. So let's go ahead and do that. And actually, one thing, I don't know if as you guys are doing this lab, if any of you guys run into this issue where when you have point-to-point everywhere, OSPF starts acting freaky. Like it'll join the edition C, like it'll get the neighborship, then break, then it'll reform again, then it'll break. As we're seeing right now, it's kind of going up and down, and that's because we have point-to-point. It thinks it's a point-to-point when it's really not. So we can see here, we do that priority. Actually, we'll make the priority 200 as well. We'll follow the doc here. So it'll be the DR. Yeah, so int 0, IP OSPF network. We'll do the broadcast. We'll just shoot it everywhere. And I'll also change the priority to 200. We also have to do it on router 2 and router 3 as well. Make sure everybody's talking the same thing. Okay, still need to wait. Okay, it's still doing its thing. This is a good thing, at least from router 1 I can see router 2 and router 3, so this is a good thing. Oh yeah, that's another good thing. Yeah. Paul brings up a good point. Documentation also mentions that our spokes, or the branch routers, should have the priority to 0. I mean, it's not, 100% necessary, because by default, I mean, if the hub's already 200 and the spokes are at 1, but it's a good way to hard code to make sure that that there's no way of these guys ever becoming DRs. And let's see what we get. Okay, so it is a DR. That's what I'm looking for. Let me see the neighbors. Full. If the hub goes down and the election happens, there's no preemption. Election is won. Well, if the hub goes down and in our topology, if that's the only hub in town, then the whole DMVPN setup, has gone to shit basically. So best practice would say we have a second hub in place. So if all our hubs are down, I think we have a bigger issue than a spoke becoming the DR. So finally, for DMVPN Phase 2, well, I kind of put the answer in here, but do we have to do anything to get it working properly? So let me do a show, or you better just do a ping. I could ping 4 to 5. So we do a trace route. And you can see here that it's going directly to 100.3. It's not going to 100.1. So Phase 2 is already, I guess you could say OSPF Phase 2 is already taken care of for us. And it's not necessarily, because DMVPN and OSPF are in cahoots. It's just that it's just by design, that's the way it's set up. And that is it for this topology. So let me just bring this guy back here. So once again, guys, if you guys want a copy of this PowerPoint, let me know, email me. More importantly, like these 2 key slides are nice. It's like a nice way where everything you want to know DMVPN wise is a good jump off or starting point for you guys, along with a kind of quick cheat sheet for the config here. And that's it for me, guys. Let me kill the video here.